Hey there guys, welcome to my walkthrough of the November 2017 Edexcel Higher GCSE Maths Paper 3. So it's a calculator paper. Make sure you check out the description down below for lots of useful content, including the paper itself, my playlist with every Edexcel past paper walkthrough, formula video, calculator tricks, and topics to help with this paper. Okay, let's do this. Question 1. So the table shows information about the heights of 80 students. Part A wants us to find the class interval that contains the median. So, what we need to do is half the number of students, so 80 divided by 2 is 40. Now, because there are an even number of students, the median value would be between the 40th and 41st piece of data. All we need to do there is go through the frequencies and add them up as we go, and hopefully find the interval where we first get a number greater than 40. So if we go through from the top, we got 4, add 11 is 15, add 24 is 39, and then add 22 is 61. So we've gone from having 39 students to 61 students, so the median is in that interval, 160 to 170. Okay, then part B wants us to draw the frequency polygon to represent this data. So, frequency polygons, spoilers, look like this. So you need the midpoint of each interval, that's your x coordinate, and your y coordinate is the frequency. So the first point we want to plot, for example, is 135 4. So that's this point down here. So do that for the rest of the intervals, and you join the points together like this. Don't join the two endpoints together, and don't connect to the axes. Okay, number 2. In London, 1 litre of petrol costs 108.9p. In New York, 1 US gallon of petrol costs $2.83. We are told 1 US gallon is 3.785 litres, and 1 pound is $1.46. In which city is petrol better value for money, London or New York? You must show your working. Okay, so what I'm going to do is find out how much 1 litre costs in New York in terms of pounds. So, in New York, 1 US gallon of petrol costs $2.83. Now we know that 1 US gallon is 3.785 litres. So, in New York, we can get 3.785 litres for $2.83. Now, from that, we can work out how much 1 litre would cost. So, to do that, to get from 3.785 down to 1 litre, we divide by 3.785. So we can find the cost in dollars by doing 2.83 divided by 3.785. And that gives us 0.7476. So if we go to 2 decimal places, that would be $0.75. So now we know 1 litre costs $0.75. We now need to turn the dollars into pounds. So, we know that 1 pound is $1.46. So to now turn this into pounds, we now need to divide $0.75. We need to divide that by $1.46. Now if we do that, we get 0.51, and that is now pounds. So it's much cheaper in New York. Okay, number 3. A gold bar has a mass of 12.5 kilograms. The density of gold is 19.3 grams per centimetre cubed. We want to work out the volume of the gold bar, giving our answer correct to 3 sig figs. Okay, so if you can't remember the formula for density, it's given to you right there. Grams is a measure of mass, centimetres cubed is a measure of volume. So density is mass divided by volume. Now, we want to work out the volume. So, if we multiply through by V, we get volume times density is mass, and then divide through by the density. Volume is mass over density. So, our volume here is 12.5 kilograms divided by, now we need to be very careful here, because we're given the density as grams per centimetre cubed. So we have 19.3 grams per centimetre cubed. Now the top and bottom masses are in different units. So we need to turn 12.5 kilograms into grams. So this is 12,500 grams divided by 19.3 grams per centimetre cubed. Now, if we do 12,500 divided by 19.3, we get 647.6 blah blah blah. That to three significant figures is 648, and that's volume, so it's centimetres cubed. Okay, number 4. So there are only blue pens, green pens, and red pens in a box. The number of blue pens to the number of green pens is 2 to 5. So straight away, I'm going to write that down as a ratio. Blue to green is 2 to 5. Okay, then we're also told the ratio of green to red is 4 to 1. Okay, now we're told there are less than 100 pens in the box. What is the greatest possible number of red pens in the box? Okay, so what we're going to need to do is combine these two ratios into one. Now, the reason for that is we can then work out how many pens are in one lot of the ratio, and then work out the biggest multiple of that number under 100, and that's going to lead us to glory. So, to combine ratios, and I have a video on this, by now it might even be a playlist, it will be down below. To combine two ratios, you need to turn the common part of both ratios into the same number. So here the common part is green pens. Now on the left we have 5, on the right we have 4. So the first number, 5 and 4, both go in 2, is 20. So we're going to change each ratio so that the green part is 20. So on the left we need to multiply both parts by 4. So we get 8 to 20. And on the right we need to multiply both parts by 5. So we get 20 to 5. Now, as a single ratio, blue to green to red is 8 to 20 to 5. Now, if we add those together, 8 add 20 add 5 is 33. Now, if we then do 100 divided by 33, we would get 3.3 recurring. So that means then there are 3, or there can be 3 whole lots of this ratio of pens in the box. So the greatest number of red is 3 times 5. Which is 15. Okay, number 5a wants us to find the value of the reciprocal of 1.6, giving our answer as a decimal. So all the reciprocal means is 1 over that number. So we have 1 over 1.6. Now, as a decimal, that is going to be 0.625. Okay, then for part B, just round a number x to one decimal place. The result is 9.8. We want to write down the error interval for x. So my error interval stuff is down below. So if you've rounded to one decimal place, your bounds of your error interval are going to have two decimal places. So we're going to have x in the middle. Now, for the lower bound, we're going to have, so we want the smallest number that would round up to 9.8. So that's 9.75. Now for the upper bound, you use a strict inequality, and you have the smallest number that wouldn't round down to 9.8. So that would be 9.85. Okay, number 6, forming and solving equations. So here is a rectangle, true story. We're told the length of the rectangle is 7 centimeters longer than the width. So straight away, let's process that. If we call the width x, then the length is 7 more than that. So that's x add 7. Cool. Okay, so then we're told 4 of these rectangles are used to make this 8-sided shape. We are told that the perimeter of the 8-sided shape is 70 centimeters. We want to work out the area of the 8-sided shape. Okay, so what we need to do is form an equation using the fact that we know the perimeter. What that's going to allow us to do is find the value of x. When we know that, we can then find the area of the rectangle. So let's go around this 8-sided shape and label what we can. So we're thinking in terms of perimeter. So we know here, that's going to be x. We know this is going to be x. We know this bit is x add 7. We know this bit is x add 7. What about the top and bottom bit? Well, we know this part is x, this part is x add 7, so all together that's 2x add 7. Now we got another one of those on the bottom. Okay, now that leaves 2 lengths, which is this bit here and the same one down here. So what length is this? Well, we know the whole bit of the rectangle is x add 7. We know this bit is x, so we know this whole bit is x add 7. That means then this bit has to be 7. So that is then going to be the same down here. So now we can work out the perimeter algebraically. So if we start here, we have x, so I'm going to add all the x's together first. So we have x, add x, which is 2x, add 2x is 4x, add x is 5x, add x is 6x, add 2x is 8x. So we have 8x. And then let's add the numbers together. So we got 7 and 7 is 14, add 7 is 21, add 7 is 28, add 7 is 35, add 7 is 42. So we know then 8x add 42 is the perimeter algebraically. Now we also know the perimeter is 70 centimeters. So we can set the algebra now equal to 70. And that now allows us to find the value of x. So if we subtract 42, and then we get 8x is equal to 28. And then if we divide by 8, we get x is 28 over 8, which is 3.5. So now we know that the rectangles have dimensions 3.5 centimeters by 10.5 centimeters. So then finally the area is 3.5 times 10.5, and that gives us 36.75 centimeters squared. Okay, so remember that we were asked to work out the area of the 8-sided shape. So the 8-sided shape is made of 4 of these rectangles. So the total area then is 4 times 36.75 centimeters squared. So if we multiply that by 4, we get 147. Cool. Number 7 wants us to work out 13.8 times 10 to the 7 times 5.4 times 10 to the minus 12. Giving our answer was an ordinary number. Okay, so if you work it in your calculator, exactly how it is, although you don't need the brackets. I don't know why they bother putting them in there, because when you're multiplying, you don't need them. So stick that in and you will get 7.452 times 10 to the minus 4. So we have 7.452 times 10 to the minus 4. So the minus 4 tells us the decimal is going to move 4 places to the left. So it's going to go 1, and then 2, 3, 4. So it's gonna need to be then 0.0007452. Okay, number 8. When a drawing pin is dropped, it can land point down or point up. Lucy, Mel and Tom drop the pin a number of times. The table shows the number of times the drawing pin landed point down and the number of times it landed point up for each person. We're told Rachel is going to drop the drawing pin once, whose results will give the best estimate for the probability that the drawing pin will land point up. Give a reason for your answer. Okay, so when you carry out a trial a number of times, you can get what is called the relative frequency, which is the number of times a certain outcome happens out of the total number of times the trial was done. Now the relative frequency can be used as an estimate for the probability, and it gets more and more accurate the greater number of times you do the trial. So what we need to do is work out how many times each person dropped the pin. Whoever did it the most times gives us the best estimate for the probability. So Lucy is 45 times, Mel is 80 times, and Tom is 25 times. So Mel dropped the pin the greatest number of times, so Mel, and the reason would be she dropped the pin the greatest number of times. Okay, then for part B, Stuart is going to drop the pin twice. We want to use all the results in the table to work out an estimate for the probability that the pin will land point up the first time and then point down the second time. Okay, so when it says use all the results in the table, what we're going to need is the total number of times the pin was dropped, total number of times it landed down, total number of times it landed up. So the total drops is 45 add 80 add 25, which is 150. Now from that, we work out the total number of times I landed down. 31 add 53 add 16 is 100. So that means I landed up 50 times. So the probability it lands down is 100 out of 150, which is 2/3. So then the probability it lands up is 1/3. Now if we want the probability it lands up and then down, we then do 1/3 times 2/3, which is 2/9. Okay, number 9. Jack bought a new boat for £12,500. The value v pounds of Jack's boat at the end of n is given by the formula. V is 12,500 times 0.85 to the power of n. So we're thinking in terms of compound interest, except its depreciation, and it's losing 15% of its value per year. At the end of how many years was the value of Jack's boat first less than 50% of the value of the boat when it was new? Okay, so the first thing we need to find then is 50% of £12,500. So just divided by 2, that's 6,250. So all that we need to do is play around with the formula, test some values of n. So, for example, the first one I'm going to draw is n equals 3. So, that's going to give us a value of 12,500 times 0.85 to the power of 3. And that's going to give us 7,676 pounds. Or 7,677 pounds. If we go to the nearest pound. So that's no good. Still quite far off. So now I'm going to try 5. So n equals 5. Gives me V is 5,546. So that is below. Now what I need to check is the year before to see whether that was less than or more than 6,250. So n equals 4 gives me V is 6,525. So that is more than 50% of the original price. So the answer is n equals 5. Okay, then for part B, a savings account pays interest at a rate of R% per year. Jack invests £5,500 in the account for 1 year. At the end of the year, Jack pays tax on the interest at a rate of 40%. After paying tax, he gets £79.20p. We want to work out the value of R. Okay, so it's reverse percentages. So we know he gets paid the interest, but then he gets taxed 40% of it. So after he's taxed, he has £79.20 left, which is 60% of the interest. So we can say 60% of the interest is equal to 79.20. Now, what we need to do from that is find what the interest was, and then we can find out what percentage the interest pays. So, from 60% we need to get to 100%. To do this, first of all we're going to divide both sides by 6 to get 10%. So 7920 divided by 6 is a number. That is 13.2. So that's £13.20p. So that means then that 100% of the interest is £132. So what we then need to know is what percentage is that of 5,500. So R is 132 out of 5,500 times by 100. And that is going to give us 2.4. So R is 2.4. R percent is 2.4%. Okay, number 10. There are only blue counters, yellow counters, green counters, and red counters in a bag. A counter is taken at random from the bag. The table shows the probabilities of getting a blue, a yellow, or a green counter. Part A wants us to work out the probability of getting a red counter. So, probability always has to add up to 1. So if we add up the others and subtract it from 1, then we get our answer. So 0.2 add 0.35 add 0.4 gives us 0.95. So 1 minus 0.95 is 0.05. Okay, and then part B asks us what is the least possible number of counters in the bag. You must give a reason for your answer. Okay, so there has to be a whole number of each counter in the bag. So these probabilities need to represent whole numbers of counters. So the easiest way to do this would be to turn each of them into a fraction, and whichever one has the biggest number on the bottom, that number is the smallest possible number of counters. So for example, blue had 0.2. And remember, your calculator can do this: stick it in, press equals, and you will get 1/5. So that only needs for there to be 5 counters in the bag. Yellow, 0.35. Well, that's 7/20. So yellow needs for there to be at least 20 counters in the bag. Now if we do that with the other two, 0.4 is 2/5. 0.05 is 1/20th. So there needs to be 20 counters in the bag at least. Okay, number 11. The cumulative frequency graph shows information about the weights of 60 potatoes. So we got the cumulative frequency at the side, the weight of potatoes along the bottom. Part A wants us to use the graph to find an estimate for the median weight. So the median is the middle. For this, we halve the frequency, which here is 30. Find that over here. Go across until we hit the graph. And then go down to find the weight. So on the real thing, you probably want to draw straight lines. So here we are there. So the scale is 10 little squares represents 10 grams. So every little square is 1. So this would be 57 grams. So the answer to part A is 57 grams. Okay, then for part B. Jamil, maybe, says that 80 minus 40 is 40, so the range of the weights is 40 grams. Is Jamil correct? You must give a reason for your answer. Okay, so where his numbers are coming from are that 40 is the smallest number down here, and 80 is the biggest number that the graph goes across to. However, cumulative frequency is all about grouped data, so we don't actually know anything about any individual weights of potatoes. So the heaviest one might not necessarily be 80, and the lightest one might not necessarily be 40. So no, Jamil is not correct, because really we are dealing with grouped data. Okay, then part C wants us to show that less than 25% of the potatoes have a weight greater than 65 grams. Okay, so this time we start on the x-axis, find 65, go up until we hit the graph. So that's at that point there. So it's only an estimate again because we're in grouped data territory, where the number of the potatoes on the graph with a weight greater are these ones. So now we go across. So we've come across to this point here, which would be 49. So then we do 60 minus 49, which is 11. 25% of 60 is 15, 11 is less than 15 cube. Okay, number 12, even more probability. I am loving it on this paper. So, Alan has 2 spinners, spinner A and spinner B. Each spinner can land on only red or white. So the probability that spinner A will land on red is 0.25. The probability that spinner B will land on red is 0.6. The probability tree diagram shows this information. Okay, so it's all already done for us, so that's nice. We are told Alan spins spinner A once, and he spins spinner B once. He does this a number of times. The number of times both spinners land on red is 24. We want to work out an estimate for the number of times both spinners land on white. Okay, so the number of times both spinners land on red is 24. Okay, so what we can do is work out first of all the probability that both spinners land on red. So let's do that. So we'll call this the probability of red. So when you're playing with tree diagrams, you multiply along the branches. So we're going red and then red. So we are doing 0.25 times 0.6. Now that will give us 0.15. Now that means that when you expand the spinners this number of times, it should be, in theory, that 15% of the time, because 0.15 is 15%, 15% of the time you should get red and then red. So what we can do from this is use the fact that he got 24 reds, the probability is 15%, we can work out an estimate for the number of times he spun the spinner. So estimated, well, 15% of estimated total spins is 24. Now, if we think about this in terms of reverse percentages, from that we can get that 5% by dividing by 3 is 8. So then 100% times by 20 is 160. So what we're now going to do, and I can't write in white, so we use blue. What we want to do is work out an estimate for the total number of times both spinners will land on white. So we now need the probability of white and white. So this time we are going along that and along that. So this time we're doing 0.05 0.75 times 0.4. So the probability white is 0.75 times 0.4. Now that is going to give us 0.3. So, to get the estimated number of times that we get white, we do 0.3 times our estimated total spins, 160, which gives us 48. Cool. Okay, number 13 wants us to write the quadratic x squared at 6x minus 7 in the form x add a squared add b, where a and b are integers, so whole numbers. Okay, so this chap here is completed square form. So I've got a whole playlist on this down below. It's nothing scary. So what we need is a single pair of brackets with the x in there and a square on the outside. The minus 7 can stay on the outside for now. Now, first up is to half the number of x. So half of 6 is 3. So that goes inside the bracket with the x. Now, the only other thing that we need to do is then square that number and subtract that on the outside. So 3 squared is 9. So on the outside, we need to minus 9. So we got x add 3 squared minus 16. So one thing to account for is I know a lot of you go, oh, but they got a plus b on the outside. Never take any notice of the signs. B itself here is minus 16. So plus minus 16 is minus 16. So don't worry about the fact that we got plus A and plus B. This is the answer. Okay, number 14, we have similar solids. So cone A and cone B are mathematically similar. The ratio of the volume of cone A to the volume of cone B is 27 to 8. So now I'm going to write the volume down here. So 27 to 8. Okay, we're told the surface area of cone A is 297 centimeters squared. We want to show that the surface area of cone B is 132 centimeters squared. Okay, so to do that, we need to first of all find the ratio of their side lengths. Now to get that from the volume, you cube root both parts of the ratio. So the cube root of 27 is 3 and the cube root of 8 is 2. Now from that we can work out the ratio of their surface areas. Now to get the surface area ratio, we square the length ratio. So we're going to get 9 to 4. So we now know then that the surface area ratio A to B is 9 to 4. Now we know the actual surface area of A is 297. Okay, number 15. So by the time you're watching this, there should be brand new videos on iteration, which is what this is. So check them out down below. So part A wants to show that the equation x cubed add 7x minus 5 equals 0 has a solution between x equals 0 and x equals 1. So to do this, we substitute in the values of x equals 0 and x equals 1, and if the solution is between those two, then we will get a change of sign. So 1 will be negative, 1 will be positive. So if we say that y, no, let's not do that, let's just say when x is 0, we get 0 cubed add 7 times 0 minus 5, so that's just minus 5. When x is 1, we get 1 cubed, which is 1, add 7 times 1, which is 7, so that's 8, minus 5 is 3. So that means, what's going on here, if we imagine we were just zoomed right in on the graph, then x equals 0 is here. Let's say x equals 1 is there. We've shown that somewhere between these 2 points, the graph crosses the x-axis. So the graph is equal to 0. Above the x-axis, it's greater than 0. That's why we get positive. And below, it's less than 0, which is why we got negative. Okay, then part B. Wants us to show that the equation x cubed add 7x minus 5 equals 0 can be rearranged to give x equals 5 over x squared add 7. Okay, so go. So we are starting off with x cubed add 7x minus 5 is equal to 0. Now, something to notice over here is that there is no x cubed. So, what we can do is, if we first of all add the 5, then we get x cubed add 7x is equal to 5. Now on the left, there's a common factor of x. So if we factorize, we get x times x squared add 7 is equal to 5. And then if we divide both sides by the bracket, we get x is 5 over x squared add 7. Boom. Okay, then for part D, by substituting your answer to part C into x cubed add 7x minus 5, comment on the accuracy of your estimate for the solution to x cubed add 7x minus 5 is equal to 0. So the whole point of iteration is trying to find a value of x that makes equations equal 0. So if you put our answer in from part C, here's a nice way to do it. Put in the answer, press equals, and then again use the answer button. Wherever there's an x, put in answer. So I put it in as answer cubed add 7 answer minus 5, and you get this minus 5 point blah 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 times 10 to the minus 3. So that is a really small number. So it's very close to 0. So it's quite accurate because it's close to 0. Number 16, we have bounds. So the petrol consumption of a car in litres per 100 kilometres is given by the formula. Petrol consumption is 100 times the number of litres of petrol used divided by the number of kilometres travelled. Nathan's car travelled 148 kilometres correct to 3 sig figs, and it used 11.8 litres of petrol correct to 3 sig figs. Nathan says, my car used less than 8 litres of petrol per 100 kilometres. Could Nathan be wrong? You must show how you get your answer. Okay, so Nathan is saying his car used less than 8 litres of petrol. So for him to be wrong, we would need his car to use more than 8 litres of petrol. So what we need to do is find the upper bound for the petrol consumption. So what we're going to do first of all is write down the error intervals for the distance and the petrol used. So for the distance, well, it's 148 kilometres to 3 sig figs. So our error interval is going to have 4 significant figures on both bounds. So the lower bound would be 147.5, and the upper bound, remember you use a strict inequality, would be 148.5. Now, for the petrol used, our lower bound would be 11.75, and our upper bound would be 11.85. So, if we look at the formula, up on top we have 100 times the number of litres of petrol used. On the bottom we have the number of kilometres travelled. So the petrol consumption, or the upper bound, so for that to be as big as possible, we want the biggest number on top, so that's going to be 100 times 11.85 So that's the upper bound of petrol used. And then, so if we have the biggest possible number on top, we need to divide by the smallest possible number. So on the bottom, we are dividing by 147.5. Now, if you stick that in your calculator, you will get 8.03 blah blah blah. So, yes, he could be wrong. Okay, number 17. This is a pain in the ass. We're going to need 3 types of trig. So we're going to need area of a triangle with trig, sine rule, and cosine rule. So if you haven't already, check out my formula video down below, where you can also get a printable PDF. So ABC and ADC are triangles, true story. The area of triangle ADC is 56 meters squared. Work out the length of AB correct to 1 decimal place. Okay, so the length that we want is this guy here. Now, in this top triangle, all we know at the moment are 2 angles. If we could find the length AC, we could then use the sine rule, because we then have a matching pair of angle and side. But we don't know that. So then we go down to the bottom triangle and think about what we know and what we can find. So we do know that the area of this bottom triangle is 56 meters squared. Now, we can use the area of a triangle with trigonometry then to find the length DC. When we know that length, we can then use the cosine rule to find the length AC. So, let's first of all find DC. So, in this triangle then, we have, well, let's recap. If we call that theta for now, this side A, this side B. Area is then 1/2 AB sine theta. So, if we plonk in what we know theta is 105 and A is 11. So, we then know then that 1/2 times 11 times B sine of 105 is equal to 56. Now if we multiply both sides by 2 to get rid of the fraction and rewrite the left a bit, so I'm going to say the left is B times 11 sine 105, and that is equal to 112. Now if we divide by 11 sine 105, B is 56. No, 112 over 11 sine 105. So work that in your calculator and you should get 10.5 meters. So, what we now know is the length of that side. Okay, so now that we know that, we can now use the cosine rule to work out AC. So by the cosine rule, we know that AC squared, so that top length, is equal to 11 squared add 10.5 squared minus 2 times 11 times 10.5 cos of 105. So, let's see what we get for that. Okay, so we should get that is 291. AC then is the square root of that, which to one decimal gives us 17.1. So now we know this length. So now finally, by the sine rule, let's see, so we know this angle C, so we'll call this side little c, and this angle up here is called big B, so we'll call this side little b. By the sine rule, C over sine 48 is equal to 17.1 over sine 118. So if we multiply through by sine 48, we get C is 17.1 sine 48 over sine 118. So that is going to give us a number that gives us 14.39 blah blah blah. They want the answer to one decimal place, so we get 14.4 meters. What a massive pain that question was. Okay, number 18. Here's a speed time graph for a train. Exciting stuff. So we have speed in meters per second, going up the side, and time in seconds along the bottom. Part A wants us to work out an estimate for the distance the train travelled in the first 20 seconds. Use 4 strips of equal width. Okay, so distance travelled on a speed time graph is represented by the area under the graph. So when it says use 4 strips of equal width, we want to split 20 into 4, so 20 divided by 4 is 5, so each strip is going to be 4 wide. 5 wide. So then what we're going to do, we're going to draw triangles and trapeziums and then work out their areas. So the first one is a triangle. Here's a ruler for the real thing. So we need to know the scale on the side. every 10 little squares represents 5, which means 2 little squares represent 1. So our height here is 4 little squares, which is 2. Now if we call this D1, then area of a triangle is base times height divided by 2. So D1 is 5 times 2 over 2, which is 5 meters. Now for the rest, they are going to be trapeziums, so we need to know the formula for the area of a trapezium. So the top is usually called A, bottom B, height H. Area is height times A plus B all over 2. Now our trapeziums are all going to be sat on their ends. So for us, this is going to be A, this B, and this H. So the next one is that. So this length over here is 2. This guy is 5. And our width is 5. Let's call it D2. So D2 is 5 times 5 add 2 all over 2. So that's 5 times 7, 35, divided by 2, that's 17.5. Okay, then the next one goes all the way up to there, so okay, so this time this guy is 5, this guy is 10, and our height is 5. Call it T3. T3 then is 5. T3 is 5 times 10 add 5 all over 2, that's 5 times 15, which is 75, divided by 2 is 37.5. Okay, one more time. So, now final one. As I liked all the way up here. So that height is 18. Okay, so this trapezium then has a height of 18. Or not a height, but B is 18. This guy is 10. This guy along the bottom is 5. Got a D4. Now D4 is 10 and 18. Sorry, 5 times 10 add 18 all over 2. So 10 and 18 is 28. 5 times that is 140. Divide that by 2 is 70. So now that we know 4, we can add them together and get our total. So 17.5 add 37.5 is 55, add 5 is 60, add 70 is 130 meters. Okay, then part B wants to know if our answer to part A was an overestimate or an underestimate. Give a reason for your answer. So remember, it's the area under the graph that represents the distance travelled. So I've gone back and drawn in my slanty lines properly, as you should have with a ruler, and we can see the lines go above the curve. So we've actually calculated a greater area than what's under the curve. So our answer was an overestimate. Number 19, much nicer because we don't need to faff with a calculator. So we want to prove algebraically that the straight line with equation x minus 2y equals 10 is a tangent to the circle with equation x squared add y squared is 20. Okay, so the first thing really we should start with is a sentence saying what would make this line a tangent to the circle. So I'm not going to write it just to save time, but we should really start by saying if x minus 2y equals 10 is a tangent to x squared and y squared equals 20, and then there is only one point of intersection. So only one point where the line meets the circle. Now to show that, we solve the equations simultaneously. So our equations then are x squared add y squared equals 20 and x minus 2y is equal to 10. Now, what we're going to do is we use a method called substitution. If you're rusty on this, check out my simultaneous equations playlist down below. So what this means is, using the linear equation, so that's our x minus 2y equals 10, we want to get one letter on its own. So what we can do is add 2y to both sides. So then we get x is equal to 2y add 10. Now what we're going to do with that is substitute that into the equation of the circle. So where there was an x, there it's now going to be 2y add 10. So instead of having x squared, we're going to have 2y add 10 squared. Add y squared is equal to 20. Okay, so now we have an equation purely in terms of y that we can solve to find any y solutions. So if we expand this bracket, we're going to get 2y times 2y, which is 4y squared. Remember, 2y add 10 squared means 2y add 10 times 2y add 10. So we are going to get 10 times 2y twice. So that's 20y add 20y, which is 40y. And then we're going to get 10 times 10, which is 100. And then we got add y squared. Now that is all equal to 20. Now this chap is a quadratic. To solve quadratics, you need everything on the same side with a 0 on the other. So I'm going to move that 20 and also collect the y squareds. So we have 4y squared, add y squared, which is 5y squared. And we've got 40y. Now to move to 20, we're going to minus 20 from both sides, so we get plus 80 is equal to 0. At this point, it's always a good idea to check for a common factor. So here there is one, it's 5. Divide both sides by 5, we get y squared. Add 8y. Add 16 is equal to 0. Now we can factorize that to y add 4 times y add 4, which we can then again factorize to y add 4 squared is equal to 0. From that, we can say the only y coordinate of intersection is y equals minus 4. Now we could stop there and just say, well, that shows then that there is only one point of intersection, therefore the line is a tangent. So we have done it, you would need to close it with that statement. What I'm also going to do is I'm going to find the x coordinate too, because it's good practice. So remember that we know that x is 2y add 10, so the x coordinate is 2 times minus 4 add 10, which is minus 8 add 10, which is 2. So the point, or the only intersection point, is at 2 minus 4. So again, because there's only one point of intersection, the line is a tangent. Okay, number 20, we are proving a circle theorem, so I've got a whole playlist on all of these, it's down below. So A, B and C are points on the circumference of a circle, centre O. AOB is the diameter of the circle. We want to prove that angle ACB is 90 degrees. you must not use any circle theorems in your proof. Okay, so the angle then that we want to find is this guy here. Now then, the way that we do this, pretty much the way that you start to prove any circle theorems, is you draw lines out from the centre of the circle. So we're going to draw a line from O to C, like that. Now, the reason that we do that is we've now created two isosceles triangles. So we know that OA is a radius, OC is a radius, and OB is a radius. So we have two isosceles triangles. Now they're not the same isosceles triangle. So what we're now going to do is, over in this left hand triangle, we know this angle and this angle are the same, so I'm going to call them A. Now, in the centre, if I for now call this angle X, then we know that X add 2A is equal to 180 degrees. So X is 180 minus 2A. So we can go back, get rid of the X. And plonk in 180 minus 2A. Okay. Now we do something very similar in the other one. This time we're going to call the angles B. Now, using the exact same logic here, we can say this angle is 180 minus 2B. Now, let's go to the angle that we're interested in. So, this whole angle is A add B. So we need to try and find what A add B are equal to. So that comes from the two angles at the centre. So these two angles make up angles on a straight line. So we can say 180 minus 2A add 180 minus 2B. Well, we know that that is equal to 180. Now, if we sharpen that up, we can say that 360 minus 2 lots of A minus 2B is equal to 180. Now, if we add 2A and 2B to both sides, we get 360 is 180 add 2A, add 2B. Take away 180, 180 equals 2A, add 2B. Divide by 2, we get A, add B is equal to 90 degrees, which is our angle up here. Where's the proof? Number 21, now I warn you, this question is hard. So, it's a lovely 5-mark vector question. So we're told that OAN, OMB and APB are straight lines. AN is to OA. So what that means is the length A to N is twice the length of O to A. We are told M is the midpoint of OB. O to A is little a. So this factor is little a. Now remember that we were told AN is 2OA, and that means the vector A to N is going to have to be 2A, because it's twice the length. Okay, then we're told O to B is little b. So all of that is little b. Now that also tells us O to M is b over 2, as is M to b. Okay, now then we are told that A to B is k lots of A to B, where k is a scalar quantity, so just a number. Given that MBN is a straight line, find the value of k. Okay. So, MPN then is a straight line. Okay, so what can we do? Well, let's process what we were told. So we know that A to P is k times A to B. So let's find A to B. So to get from A to B, we need to go backwards along little a, forwards along little b. So that's minus a, add b. From that on, we know that A to B is k times minus a, add b. Which we can expand to minus k a, add k b. Okay, so let's get that written down here. So A to B is minus k a, add k b. Okay, now then, what we could also do is, well, now that we know that, we can now work out vector m to n and, m to p and vector p to n. Now, because those two vectors make up a straight line, we know that they are parallel. Now that means we can think of one of them as a multiple of the other. So let's find these. So m to p is gonna be minus b over 2 add a to b. Now a to b was minus ka add kb. So we could write that as a minus ka add kb minus b over 2. So that gets us from m to p. Okay, so m to p is that vector. Now, we can also work out p to n. Now, for p to n, we're going to have to go backwards along a to p. So that's negative of this. So that's ka minus kb. And then along to a. So we can write that as 2a add ka minus kb. So that gets us from p to n. Okay, so now then, at this point, we know two parts of the same line. Now, because they lie on the same line, that means they are parallel. When vectors are parallel, it means one of them is a multiple of the other. So, it was at this point where I said out loud, what the fuck are they doing? Putting a question like this on a GCSE paper, because it's about to get pretty tricky. So, we can say that, well, first of all, actually, let's factorize both vectors. So for this guy, we can say we have 1 minus ka and then add k minus a half b. And then for this guy, we have 2 add ka minus kb. Okay, now again, because they are parallel, we can say that one vector is a multiple of the other. So what that means is we multiply one vector by a number and we get the other vector. So, I'm going to say that I'm going to say b2n is x as our scale factor, if you like, times m2b. So, b to n is x times m to b. So, what that means is then that b to n, so to add k, a minus kb is equal to x times 1 minus ka, add x times k minus a half b. Now, if we compare the coefficients on each part of the vector, this then means that 2 add k is equal to 1 minus k, sorry, x times 1 minus k. Now from that, we can get that x is equal to add k over 1 minus k. Now, if we do the same for the b's, we can say then that minus k is equal to x times k minus 1/2. From that, we can get that x is minus k over k minus 1/2. Now, we have two expressions in k now for x. So, if both of these things are equal to x, then they are equal to each other. So we can now say 2 add k over 1 minus k is equal to minus k over k minus 1/2. Now we need to solve this for k. Okay, so what we're going to do then is multiply through by the bottom of each fraction. So on the left, we're going to get 2 add k times k minus a half, and that is equal to minus k times 1 minus k. Okay, now we need to expand both sides. So on the left, we are going to get k squared. Now we would get 2k minus 1 half k, so that's 3 halves k. And then we got 2 times minus a half, so that's minus 1. And on the right, we're going to get minus k times minus k, so that's positive k squared. And then minus k times 1 is minus k. Now we're nearly there, the worst is over. So we have a k squared on both sides, so we can take those away. So we then got 3 halves k minus 1 is equal to a minus k. Now if we add k to both sides, k is 2 halves k, so if we add that to 3 halves k, we get 5 halves k. Minus 1 is equal to 0, add 1, 5 halves k is equal to 1. Now then, if we multiply through by 2, 5k is 2, and then finally, k is 2 fifths, which is our answer. What an absolute dick of a question. Okay guys, that's the paper done, and my voice. Hope you found it useful. Don't forget, give us a thumbs up, get subscribed. Every paper is in the playlist down below. Take it easy, take care.